Did you know that a gas can light up a miner's path and weld the world's tallest skyscrapers? In this video, we'll take you on a journey through the evolution of acetylene from its humble beginnings in the lab to its powerful impact in today's industries. Have you ever wondered how a gas could be so versatile? Let's find out together. In 1836, acetylene was accidentally discovered by Edmond Davy. However, French chemist Marcellin Berthelot fully identified and named it, recognizing its potential in chemistry and as a fuel. Now, let's explore the fascinating properties of this versatile gas. Acetylene is a colorless gas with a garlic-like odor, highly flammable and capable of forming explosive mixtures with air. Due to its instability, it shouldn't be stored at pressures above 22 psi in its gaseous state. For practical storage, acetylene is dissolved in solvents like acetone in special cylinders, making it safe at pressures below 220 psi. In industry, it is mixed with certain chemicals to give acetylene a more noticeable odor, making leaks easier to detect. Acetylene, as a member of the alkyne family, undergoes various reactions. For instance, when burned with oxygen, it produces carbon dioxide, water, and energy, exemplified by carbide lamps that once illuminated mines and railroads. The energy is equal to light and heat. Carbide lamps are an example for this reaction. Carbide lamps burned acetylene gas to produce bright flame, which was used to light caves, mines, railroads, homes. While carbide lamps were essential tools for miners, their explosion risks due to mine gases have led to the adoption of safer LED headlamps and cap lamps today. Oxygen-acetylene gas mixture welding is another example. Oxygen and acetylene gases mix in the torch and are ignited. They produce water, carbon dioxide, and a bright heat which can reach approximately 6,332 degrees Fahrenheit. Produced heat is used to join, cut, braze, or heat metals. This welding has significantly contributed to the growth of the metal industry, particularly in the construction of cars, steel bridges, trains, ships, planes, and more. Oxyacetylene weldings are still used today for their portability, cost, no need electricity, and heat. Acetylene reacts with hydrochloric acid to produce vinyl chloride, which is used to make PVC. PVC is widely used in many everyday products, including pipes and fittings, vinyl flooring, window frames, electrical cable insulation, credit cards, medical equipments, and etc. Acetylene reacts with hydrogen cyanide to form acrylonitrile, which is used to make Orlon. Orlon is used in carpets, clothing, blankets, upholstery, outdoor fabrics, yarn, sportswear, stuffed animals, crafts, and industrial applications. When acetylene is passed through a special solution, it forms vinyl acetylene, which is used in the preparation of a type of synthetic rubber. Swimsuits, laptop sleeves, belts, orthopedic braces, and other more stuffs made form this type of synthetic rubber. Water is added to acetylene to form primarily acetaldehyde, which is used to make acetic acid. Acetic acid, derived from acetaldehyde, is used in vinegar, food additives, cleaning products, medical solutions, industrial chemicals, cosmetics, pharmaceuticals, and agriculture. Acetylene is found in trace amounts in nature and has been detected on the planet Jupiter. Due to its limited natural occurrence, acetylene is primarily man-made. The most common industrial process for producing acetylene is the calcium carbide process. The calcium carbide process, a common industrial method, involves adding calcium carbide to water to produce calcium hydroxide and acetylene gas. It's important to ensure the gas is not mixed with air to avoid danger. Acetylene's journey from the lab to its diverse industrial applications highlights its versatility and importance. Thanks for watching. If you enjoyed this video, please like, subscribe, and share your thoughts in the comments below.